In 1801, an astronomer named Giuseppe Piazzi discovered the largest asteroid in the solar system. At that time, people believed that there should be a planet between Mars and Jupiter, and Ceres seemed to fit this hypothesis. However, just a year later, another astronomer, Heinrich Olbers, discovered another orbit. It was later named Pallas. This discovery helped Olbers speculate that these two celestial bodies might be fragments of a planet. Subsequently, with the successive discovery of the asteroids Vesta and Juno, this theory received further support. People believed that the planet that once existed had shattered in the early period of the solar system, and the debris formed what we now call the asteroid belt. This theory is known as the fragmentation theory. At that time, astronomers generally thought that this planet had collided with a large celestial body, ultimately leading to its destruction. The most likely collision targets were a hypothetical red dwarf or brown dwarf in the solar system. Additionally, there's a theory that this planet may have undergone some internal catastrophe leading to its self-fragmentation. Some people also believe that the planet was torn apart by the powerful gravitational pull of Jupiter as it approached its parent star. However, today astronomers no longer believe in the fragmentation theory. Instead, a new theory called the aggregation theory has replaced it. This theory posits that the asteroid belt is a participant of the protoplanetary disk. This protoplanetary disk was already rotating around the Sun in the early solar system, but due to Jupiter's strong gravitational influence, the materials that should have coalesced into a planet failed to fully aggregate, ultimately forming the asteroid belt as we know it today. So, what exactly is the asteroid belt? It is located in the orbit between Jupiter and Mars, filled with countless asteroids. These celestial bodies sometimes migrate and are even ejected from the asteroid belt into the outer solar system by Jupiter's powerful gravity. The four largest asteroids in the belt are Ceres, Vesta, Pallas, and Hygeia. Together, their mass accounts for half of the total mass of the asteroid belt, while the remaining mass is composed of thousands of smaller celestial bodies. In many science fiction movies, plots often depict protagonists venturing into the asteroid belt, facing the danger of innumerable asteroids colliding with their spacecraft. However, this is vastly different from reality. Although there are thousands of asteroids in the asteroid belt, the distances between them are very large, making the likelihood of collisions almost zero. During the formation of the asteroid belt, some celestial bodies began to collide with each other, gradually forming the so-called protoplanetary bodies. However, due to Jupiter's gravitational interference, the intensity of these collisions was too great, and the material that should have accumulated into larger celestial bodies could only form smaller ones. Astronomers believe that due to such intense collisions, the original mass of the asteroid belt was reduced by more than 99.99% during the early history of the solar system. Today, only the largest asteroids can maintain sufficient gravity to form an approximately spherical appearance, while smaller asteroids are often merely composed of loose rocky fragments held together tightly by gravity. Dust-like tiny objects cannot form any obvious structures and exist in the asteroid belt like dust. These large and small celestial bodies all orbit the Sun based on their albedo. We can classify them into several main types of asteroids, including C-type asteroids, S-type asteroids, and M-type asteroids. The first two types account for about 75% of the total known asteroids. The asteroid belt first traversed by Pioneer 10 spacecraft. This groundbreaking discovery refuted the earlier theory that the asteroid belt was filled with dust and could potentially damage spacecraft. In reality, the probe did not suffer any significant damage. Since then, there have been 8 more probes. The age of the solar system has exceeded 4.5 billion years. Scientists reached this conclusion by studying meteorites, which are the oldest materials they can find. However, our solar system is not the only existence in the universe. In our galaxy, there are about 100 billion star systems. And if it's just our galaxy, imagine what the entire universe would be like. Moreover, our Sun is also an extremely massive celestial body. The Sun accounts for 99.86% of the total mass of the solar system, primarily hydrogen and helium, remaining 0.14% others. Contrary to common belief, outer space isn't a complete vacuum. In addition to stars and planets, it contains interstellar dust, space plasma, and cosmic rays, atomic debris entering from the vast masses of the 8 solar system planets. The edge of the solar system. Astronauts must pay special attention to a phenomenon called cold welding when exploring space. Cold welding refers to when two objects made of the same metal come into contact in space. They bond together firmly and become one, like watering the universe. This phenomenon does not occur on Earth because water and air can separate metal objects. You must know that although the Moon is 400 times smaller than the Sun, its distance from Earth is exactly 400 times that of the Sun, so it can completely cover the Sun. 600 million years later, with changes in the Moon's orbit, it will no longer be able to completely block the Sun. Behind Neptune's orbit exists a mysterious Kuiper belt, filled with massive icy bodies. What is even more curious is that scientists cannot explain the movement patterns of this group of celestial bodies. The only current explanation is that Neptune might be hiding a giant planet. This hypothetical planet is called the ninth planet. Whether it has been confirmed to exist is still unknown. The oceans on Jupiter are larger than any water bodies on other planets in the solar system, but they are not the kind of oceans we typically understand. Jupiter's oceans are not composed of water, but of metallic hydrogen, with a depth of about 25,000 kilometers, almost comparable to the Earth's circumference. Since the 17th century, when people first observed the beautiful rings of Saturn, we have known that Saturn is not the only planet with rings. All gas giants, Uranus, Neptune, and Jupiter, have their own rings, although they are very thin and almost invisible. Rocky planets like Mars, Venus, and Earth do not have rings. Meanwhile, Saturn's moons may have a ring system composed of 3 narrow rings. If astronomers can confirm this, it would be the first time humans have discovered a ring system surrounding a moon. Mars might also have its own rings within the next 70 million years. The largest moon of Mars, Phobos, is orbiting Mars at an increasingly close distance. In the future, it is likely to be torn apart by Mars' gravity and transformed into a ring that could exist for millions of years. Another interesting fact about Mars is that many have heard of methane gas, which is a byproduct of natural processes like volcanic activity and cattle emissions. However, methane is not just a part of Mars' atmosphere. Its presence continues to puzzle astronomers. Scientists have found that the methane levels in Mars' atmosphere fluctuate, making it difficult to precisely explain its source. Could there be life on Mars?